Welcome students. Now we will see inverse discrete Fourier transform by using fast Fourier transform method. So we have a question like why we are going for fast Fourier transform algorithm. So here when we perform any operations by using discrete Fourier transform, how many number of additions are required? So if you look into this, the formula is given by n into n minus 1. That means take one example, when you take n is equal to 4 point DFT, see how many number of additions are required. So 4 into n minus 1, that means 4 minus 1, that is 3. So it requires almost 12 operations. So 12 additions you need to perform to complete one DFT operation. Similarly, multiplication. If you have n is equal to 4, how many number of multiplications you have to perform? Almost 16 multiplications are required. Let us go for fast Fourier transform and see if n is equal to 4 for the same operation, it is being reduced by 4 log to 4. That means it is reduced to 8. And here 4 by 2, that means 4 by 2 log to 4. The multiplications it required is 4. See, your 12 number of additions has been reduced by 8 and multiplications which is required in DFT is 16. By using FFT, you can reduce it to only 4 multiplications. So, which one is best method to perform the DFT operation? So, for fast Fourier transform method is the best one which will reduce the computations. Let us take one more example. If n is equal to 64, let us see how many multiplications it required. So, 64 square means 4096 multiplications are required. But when you go for here, it requires 32 log to 64. That means here log to 64 means 6. 6 into 32 which gives you 192 multiplications. So where is thousands and where is in 100 units. So there is a lot of reduction when you are performing by using fast Fourier transform. That's why we are going for fast Fourier transform. Now in fast Fourier transform there are two methods. One is decimation in time and decimation in frequency. Today in this session we are going to see decimation in time fast Fourier transform algorithm. So for this, now we have to look into the question and then we have to see what are the necessary steps to solve the problem. Okay. First one is, we need to know a few more basics, that is how to write e power j2 pi, means e power minus j2 pi. It is represented with equivalent to w. That means in frequency domain it can be also be represented with w. If e power minus j2 pi is multiplied with k, then your w will be multiplied, or it is represented with the power of k. Now, if the expression e power minus j 2 pi k by n means w power k and divided by n will be represented with suffix n. So, this is the way how your exponential terms can be easily or conveniently represented by using this one. So, this term is called as twiddle factor. Twiddle factor, which is used to represent the exponential terms. Okay. Now let us see here. If we find out the twiddle factor like this, and we will keep it aside this topic, but we will find out few parameters like this by taking k is equal to 0 and n is equal to 8. Okay, so then you will get e power 0, which is equal to what? 1. Now we will take if w 8 point DFT and but it is k is equal to 1, then it is becomes, substitute in this expression e power minus j 2 pi into 1, k means 1, divided by 8. So what you will get? E power minus j pi by 4. That means you can write this exponential e power minus j theta as cos pi by 4 minus j sin pi by 4. That is equal to 1 by root 2 minus j sin 1 by root 2, which can be represented as 0 0.707 minus j 0.707. So this is the value. Instead of writing it 1 by root 2, you can also write like this 0.707 minus j 0.707. Similarly, if I write w 8 power minus 1, then it becomes e power j 2 pi by 8. That means e power j pi by 4. It equals to cos theta plus j sin theta. Hence, you will get 0.707 plus j 0.707. I think it is clear for you. That means if we write w power minus 2 and it is 8 point DFT, then it is simply, you can write it as j, and w 8 power minus 3 can be written as 0.707 minus j plus j 0.707. That means we just have seen that it is e power minus j 3 pi by 4, that is cos 3 pi by 4 is minus 0.707 plus j, you get here j 0.707. So you will get the equations like this. Once again, I will summarize the twiddle factors for this. W power 0 for 8 point DFT is e power 0, which is equal to 1. Twiddle factor for 8 power minus 1 is given by cos pi by 4 plus j sin pi by 4, which is given as 0.707 plus j 0.707. W 8 power minus 2 is given as j. W 8 power minus 3 is given by minus 0.707 plus j 0.707. So these are the prerequisites. That means minimum 4 twiddle factors are required. Hence, these are the common thing for solving any DFT problem. So hence we need to be aware of solving twiddle factor. So now we learned about solving the twiddle factor. Now let us go for one more topic, like how to find out if, for example, 4 point DFT or 8 point DFT is given. How many number of stages are required to solve the problem? That further it is given by m is equal to log 2 power n. Now if I substitute n is equal to 8, your number of stages m becomes m is equal to log 2 power 8, can be written as log 2 power 3 base 2, which can be written as 3 log 2 power 2. That means it is equal to 3. So 3 stages are required to compute a DFT. So this is the formula to remember. To solve how many number of stages are required if DFT number, I mean how many point DFT, n point DFT, to compute number of stages here, m can be given by log 2 power here. Now let us solve one problem here. I think it is visible to you all, as the students, some are absent to the class, some are not able to understand few more points here, some are missed the basic concepts. That's why I am just making this video, try to catch all the points, watch until I solve this problem. Okay, find inverse discrete Fourier transform of a sequence. So here the discrete Fourier transform x of t is given here as 20 minus 5.828 minus j 2.414, like this. There is some sequence given here. Now let us give the numbering for this. So 20, I have given the numbering 0. For this number, I have given the number 1. So 2, 3, 4, 5 and 6 and 7. Totally 0 to 7 numbers are there. So the DFT length is 8 point DFT. So for computing this 8-point DFT, how many numbers of stages are required? M is equal to log 2 power n. So if it is 8, then how many stages are required? 3 stages are required. Now let us see. Inverse discrete Fourier transform can be performed by using fast Fourier transform algorithm, and the method is decimation in time. So here we will solve this by using butterfly diagram. So what is about, we will see about what is the butterfly diagram. So here there are two lines. In these are two variables and they are connected like this, and here the B letter is multiplied with the twiddle factor. Okay, here this is K and this is N. So here if you go here, you will get A plus B into twiddle factor n power K like this. But when you are crossing this line, you will get A minus B twiddle factor K N. So this is the basic diagram where on the upper portion you are multiplying with plus 1, but here the lower portion you are multiplying with minus 1. So A plus B into W n power K. So you are multiplying with twiddle factor. So this is about a small introduction about a 2-point DFT. Now we will try to solve 8-point DFT, because here in this problem 8 points are given DFT problem. So we will try to solve this one. Okay. How to draw 8-point DFT now we will see. Okay. So there are some sequence given here. So here we will write down that x of 0, x of 1, x of 2 and x of 3, x of 4, x of 5, x of 6 and x of 7. Out of this now we have to write down the even terms. So what are the even terms here? X of 0, x of 2, so x of 4 and x of 6. Similarly, odd terms, x of 1, x of 3, x of 5 and x of 7. Out of this again, so remove this, directly you can also write the even terms like this and odd terms like this. And from this we can pick out again the even terms. That means pick out the even terms from the sequence x of 0, next even number is becomes x of 4. Then after the even sequence is x of 2 and x of 6. So x of 2 and x of 6. Similarly, if you go for odd sequence, x of 1 and x of 5 is the next sequence. X of 1, x of 5, x of 3 and x of 7. Now looking into the sequence, now we will try to fill out what is x of 0. It is 20. I think it is not visible. This is 20. Next, x of 4 means what? 0. X of 2 means again 0. X of 6, you can just look into here. X of 6 is 0. So here keep 0. Okay, next. X of 1, which is given as here minus 5.828 minus j 2.414. Okay, this is the sequence. Similarly, here x of 5. X of 5 is 0.172 plus j 0.414. Okay, next x of 3. What is x of 3? The same sequence, but it is minus. So the same sequence 0.172 minus j 0.414. I think x of 7 will be the complex conjugate for this. 5 minus 5.828 plus j 0.414. I think it is visible to you. Now we will try to solve the 2-point DFT first. So we know, just now we have seen that we need to do the 2-point DFT by doing like this. Let us solve this. 20 is passing like this. 20 plus 0 becomes what? Here there is a twiddle factor. Yes, we have a doubt like this. 8 power 0. W 8 power 0 is almost, it is equal to what? It is equal to 1. So there is no need to write out W power 8. So multiplying with 1 is not necessary. So I am not mentioning here. Now 20 is passing like this and 0 is added to this. So it doesn't make any change. 20. Now if you see here, 20 is passing like this. 0 into anything is 0. You got the value here also 20. Now here 0 in 0 plus 0, 0 minus 0. You got the answer like this. Now let us see here. Minus 5.828 minus j. So this twiddle factor is multiplying with minus 1 and here minus 1. So shall we solve this here now? Inverse discrete Fourier transform, hence the x value should be a capital X of 0. All the x values are capital X only. We are computing inverse discrete Fourier transform, so the values are x. Okay, please make a note of this. We are solving the inverse discrete Fourier transform, hence we will get small x of values, I mean discrete Fourier transform at the output. So we are solving now. So here, when you do the 2-point DFT here, a plus b operation we have performed, and here you got 20 plus 0, 20, 20 in plus 0, here we got 20 minus 0 is 20, 0 plus 0, 0, 0 minus 0, 0. Here let us solve this problem. So let us write the value here, minus 5.828 minus j 2.414 plus 0.172 plus j 0.414. So here we will do the subtraction. So you will get all the values are 0 and 2 you will get next. Here both the signs are same. We will do the addition. 8 plus 2, 10, 7 plus 2 plus 1, 10. Here 8 plus 2 again 10. So we got minus 6. So we can write it as minus 6. Minus j2 is the answer at this point. Similarly, now we will do, let us keep like this as it is, but here 0.712 minus is multiplying with minus 1. So what you will get? 0.172 plus into minus becomes minus j 0.414. So what is the result here? So when you do the subtraction here, okay, what is this one? This becomes 8282. So minus j 2.828. And here you have to do the subtraction here. 8 minus 2 is 6. 12 minus 7, 5. 7 minus 1, 6. And 5. So it is minus 5.656. So we can write minus 5.656 minus j 2.828. So we got the answer like this. Similarly, the values are similar, but here we got minus 0.712 minus j 0.414. Hence, we can write this expression as, if we do the addition for this, we will get here minus 6 plus j2 here at this point. And here we will get, for the same operation, we will get 5.656, okay, minus j 2.828. So this is the sequence here. So we have completed the 2-point DFT, the first stage of butterfly figure in computing IDFT. Now let us go for 4-point DFT. Now if we see the 4-point DFT, let us compute like this, that is x of 0, okay, x of 4, x of 2 and x of 6 is 0. So how to compute 4-point DFT? How to draw? Leave one line here, draw the DFT FFT algorithm like this, multiplying with -1 and the real factor 8/0. So the sequence has to multiply with 8/0. Similarly, when you are drawing here, from the below you have to draw like this, and from below this one you have to draw like this, multiplying with -1. Here the real factor is W8/3. That means here it is equal to what is W8/3? W8/-2. 0 and 2. So you will get here J is the value you will get for this. So you need to get multiply with the J. So all the even numbers we will get. One is W8/0 and the next even number is W8/2. So you have to multiply with -2. Now let us compute here. So here this is first W8/0. Next from this point -1 W8/-2, which is equal to J. So we have to multiply with multiply with J. Similarly, here also we will write the 4-point DFT. So first one is multiplying with 1. That means W8/0 is 1. Next, we will try to solve here, multiplying with -1. You have to multiply with J. Let us see what will happen. Now if your 20 is passing like this, what is the value at this point? 0 is passing. It is multiplying with W8/0 means multiplying with 1. Doesn't make any change, so you will get 20 plus 0 is 20. Next here 20 is passing like this, so 20. And what is the value? 0 is multiplying with 0. Doesn't make any change, so it is again 20. Now here 20 is passing and it is passing like this, and here 1 means 0 into anything, so you will get again here 20. Similarly 20 is passing like this, so 20 minus anything is, 20 minus 0 is again 20. So we got the values like this. Now here -6 minus J2 is passing here, -6 minus J2 is passing here. And what is the other value you are getting here? -6 plus J2 is passing here. So this one will be added to -6 minus J2 plus -6 plus J2. What happens? -12 is the answer. So we'll write here, the answer here is -12. And now -5.656 is passing like this, and here the value which is minus, what is the value at this point? It is it's passed, and here 5.656 is multiplied with J. Now what happens to this? Let us multiply this one. 5.656 into J. J into 5.656. Next, J into J is J square. So minus J square. J square means -1. So we can write it as plus 2.828. So this is the value we got, and it is passed like this. Now we have to add the terms over here. So minus J 2.828. Next, minus 5.656. What is the value we will get here? We will do subtraction over here. 6 minus 8 means 16 minus 8 is a 6. 4 minus 2, 2. Here 16 minus 8 is again 8.4 minus 2. So minus 2.828 we got, and then here these two terms, that is again we are subtracting from the higher term, so say again we will get 8 to 8, but j, get j plus j. So we can write it as the answer as minus 2.828 plus j 2.828. Okay. Next, here while we are passing here, it has to get multiplied with minus 1. So minus 6, it becomes plus 6. Plus j2 becomes minus j2. This is the value, it's been reached at this point. Now what is the value here? Minus 6 minus j2. So what is the answer? You get cancel. So minus 4j you will get, or minus j. So you can write it as minus j4. Next, here when you are passing 5.656 through minus 1, what you will get? J, you have to get multiplied with the j as well as with minus 1. So your expression becomes j 5.656, so minus j, next minus j into square plus 2.828 multiplied with minus 1 becomes, this one becomes minus 2.828. So here we have to do the addition here. So 5.656, sorry, so here we have to write here minus j 2.828 minus 5.656. What is the answer we will get? Yes, 8 and 6 plus 8, that means 14 will get. Next it is 8, next 14 and then 8. So minus 8.484 we got. And here this again we have to add. Next this is also we got 8.484, but it is minus j. So we can write here as minus j 8.484 minus 8 point, or the j terms we will write it later. Now first we will write minus 8.484 minus j 8.484. So this is the answer we got at this point. Now how to draw the 8-point DFT? That one we have to solve. So for that, first one we need the fiddle factors. One is W8 power 0, W8 power minus 1, W8 power minus 2, W8 power minus 3. So we have to write the last 4 terms here like this: W8 power 0, W8 power 1, W8 power 2 and W8 power 3. But these are inverse discrete Fourier transform, hence we will not get the values as minus. So we will get the values like this: W8 power minus 1 is 0.707 plus j 0.707. And next for here you will get, you have to multiply with j, and here you have to multiply with 0.707. That means minus you will get plus j 0.707. So how to draw the 8-point DFT for this? Let us extend these lines like this. Start from the first one, leave 1, 2, 3 lines and then 4th point. So join these 2 lines like this. You have to multiply with minus 1. So this is 1. And next you have to multiply with minus 1. Minus 1. And then going to multiply with minus 1. Therefore, when you are passing the signals like this, here the first 20 is passing over here, or whatever the value at this point, that is minus 12, is passing like this. 20 minus 12 is 8. So we got the value x of 0 is 8. Similarly, when you are passing here, the value is 20 here. But what is the value here? W8 power 1, when it is multiplying with minus 2.828 plus j 2.828. So if you multiply here, you will get minus 4 at this point. So 20 minus 4 you will get here as 60. And next one is here, you will get here the 120 is passing here, and at this point you will get 20 is passing here, and we will get here 4 will be passing here. Then you will get the value as 24 at this point, and then here you will get 32. So since your values are like this, we can expect the other values will be like this: 32 here, 24, 16 and 8. So if you take 8 as the common, then you will get 1, 2, 3 and 4, 4, 3, 2, 1. So in a simplified manner, I am not computing the multiplication over here, but if you compute the values minus 2.828 plus j 2.828 carefully, if you do the multiplication and multiply it with minus 1, then at this point definitely you will get this value. So the sequence x of n is 1, 2, 3, 4, 4, 3, 2, 1. This is the inverse discrete Fourier transform for the given sequence, DFT sequence x of k. And this completes the solution. So always be careful while you are multiplying with minus 1 and while you are multiplying with the trivial factor. Then you will get the solution like this. Thank you.